In this video, we're going to look at uniform circular motion. Uniform circular motion occurs when an object moves with constant speed around a central point. Note that I said constant speed. However, its velocity does change due to a change in direction. This is due to an acceleration towards the center. Let's look at this. If we have an object moving in a circle around a central point, if this is its velocity, the acceleration is towards the center, and therefore it's called centripetal acceleration. The velocity is always tangent to the path and at 90 degrees to acceleration. We can find that the centripetal acceleration is equal to v squared over r. And the time it takes for the object to make one revolution around the circle is called its period, and that is equal to 2 pi circle divided by velocity. And the corollary of that is velocity is equal to 2 pi r over the period. And if we combine those two equations, we can find that the magnitude of our acceleration is equal to 4 pi squared r over the period squared. Let's go over this again by looking at some problems. A skater skates in a 12-meter diameter circle at 3 meters per second for a total time of 4 minutes. What is her acceleration? How far does she skate? And what is the period of her movement? So for part A, we want to know her centripetal acceleration, which is directed towards the center of the circle. That's equal to v squared over r. And in this case, that would be equal to 3 meters per second squared over the radius, which is 6 meters, which is equal to 1.5 meters per second squared. That is her centripetal acceleration. For part B, we want to know how far does she skate. Well, we know that distance is equal to velocity times time, and in this case that's equal to 3 meters per second times time of 4 minutes. But we also have to convert that into seconds, so we have to multiply that by 60 seconds per minute. And if we do that, we get she skates a total of 720 meters. And for part C, what is the period of her movement? Period, which is in seconds, is equal to 2 pi r over velocity. So that's equal to 2 times 3.14 times the radius, which is 6 meters, over her velocity, which is 3 meters per second. And if you do that calculation, you get a period of 12.4 seconds. Here's another problem. A man runs in a circle at 4 meters per second and a period of 8 pi. What is the radius of the circle? What is his acceleration? So for part A, we know that the period is equal to 2 pi r over v. And in this case, we're given that the period is equal to 8 pi, which is 2 pi r over the speed of 4 meters per second. If we then solve for r, we get r is equal to 16 meters, the radius of his circle. For part B, we want to know what is his acceleration. Well, centripetal acceleration is equal to v squared over r. which is equal to 4 squared over 16, which is 16 over 16, or his acceleration is 1 meters per second squared. Here's our third problem. The moon revolves around the earth at a radius of 3.85 times 10 to the 8th meters. It makes one revolution in 27.3 days, which is equal to 2.3 by 10 to the 6th seconds. What is the moon's acceleration? Well, we know acceleration is v squared over r, and in this case we have to find v first. So v is equal to 2 pi r over t, which would be 2 times 3.14 times the radius, which is 3.85 by 10 to the 8th meters, over t, which is 2.3 by 10 to the 6th seconds. And if we go through this calculation, we get v is equal to 1051 meters per second. Now we can find acceleration, which is v squared over r, which is 1051 squared over r, which is 3.85 by 10 to the 8th. And if you go through that, you get acceleration is equal to 2.9 times 10 to the minus third meters per second squared. Let's do our last problem. A satellite orbits Earth at an altitude h of 225 kilometers. At this height, g sub s equals 9 meters per second. That is the acceleration due to gravity at this altitude. The radius of the Earth, r, is 6,375 kilometers. What is the speed of the satellite? Well, we know that acceleration is equal to v squared over r. And if we substitute what's given in this problem, acceleration in this case is g sub s, and that is equal to v squared. And in this case, r would be the radius of the Earth plus the height of the satellite. If we then solve for v squared, we get v squared is equal to g sub s times radius of the Earth plus the height that it's orbiting, or v is equal to the square root of g sub s r plus h. And let's put that those figures in. That's 9 times 225 kilometers plus 6375 kilometers, where v is equal to the square root of 59.4 by 10 to the 6th, where v is equal to 7,700 meters per second.